Objective of this experiment is to determine the magnetic field at the center of the circular coil by deflection method. Formula to find the magnetic field intensity at the center of the circular coil by theoretical as well as experimental is as shown. Here, Vc stands for the magnetic field intensity at the center of the circular coil. Bh is the horizontal component of the Earth magnetic field. Theta is the deflection produced in the compass. Mu naught is the permeability of the free space. N is the number of turns in the coil. I is the electric current flowing through the circular coil, where R is the radius of the circular coil, one which carries the electric current. Apparatus required to perform this experiment is as shown: tangent galvanometer along with mounted circular coil, magnetic compass box, connecting wires, ammeter, DC power supply. Circuit connection are made as shown in the figure. This is a commutator, a device one which helps you to switch the polarity. It consisting of four terminals PQRS. Let us connect the wires. We'll start with the power supply. The positive end of the power supply is connected to the positive end of the ammeter. The P terminal of the commutator is connected to the negative end of the power supply, or in specific DC power supply. The Q terminal of the commutator is connected to the negative end of the ammeter. R, S are the terminals one which connected to the tangent galvanometer. R is connected to the common of the tangent galvanometer, and S is connected to the terminals one which gives you 20 turns, 80 turns, 60, 150. That means we can switch the terminal S to 20, 40, 60, 80, 150 turns, so that we can change the number of turns in order to increase the magnetic field in the circular coil. Let me show you again. From the positive end of the DC power supply to the positive end of the ammeter, the negative end of the power supply is connected to the P terminal of the commutator. Q terminal of the commutator is connected to the ammeter. R and S terminals are connected to the tangent galvanometer. Now let us switch the circuit. Let us switch the DC power supply. The commutator is rotated anti-clockwise in such a way that it will allow the electric current to pass through the circular coil. As soon as we pass the electric current through the circular coil, we can see the deflection in the magnetic compass box. If we rotate the commutator in the clockwise direction, the direction of the deflection in the magnetic compass box is being reversed. Now let us begin with the anti-clockwise. As soon as we turn the commutator to anti-clockwise, Deflection in the magnetic compass box is tabulated as theta 1 and theta 2. Then the commutator is rotated in a clockwise. Then the deflection in the magnetic compass box is noted as theta 3 and theta 4 as shown. And the experiment is repeated for the different number of turns in the circular coil, that is 20, 40, 60, 80 and 150. Corresponding electric current through the circular coil is tabulated. Then the deflection in the magnetic compass box is tabulated. Mean deflection is calculated. Using the mean deflection, tan theta is calculated. Using the tan theta, we can find the magnetic field at the center of the circular coil by experimental. Using the formula, BC is equal to BH tan theta. BH is the horizontal component of the Earth magnetic field. Tan theta is the deflection what we have obtained from the magnetic compass box. And theoretical magnetic field, theoretically, the magnetic field at the center of the circular coil is calculated using the formula BC is equal to mu naught times N divided by 2R times I. The calculations are made as shown by substituting the value for horizontal component as well as for the tan theta. We will obtain the magnetic field at the center of the circular coil experimentally. By substituting the values for mu naught, number of turns, that is N, divided by 2 times the radius of the circular coil into I, that is electric current through the circular coil, will give you the magnetic field at the center of the circular coil theoretically. The outcome of this experiment is we have found the magnetic field at the center of the circular coil by deflection method experimentally as well as theoretically, and they are compared